Ever heard of a shape so strange it could keep astronauts from falling on their faces? It might sound like science fiction, but this is real science. Geometry with a twist, literally. For decades, landing on the moon has been a high-stakes balancing act. Every time a spacecraft touches down, there's a real risk of it tipping over, getting stuck, or even toppling completely. But what if a bizarre, almost alien-looking shape could change all that? Well, buckle up. The moon is basically a giant sandbox with terrible Wi-Fi and even worse parking. Imagine trying to land a multi-million-dollar spacecraft on a surface that's not only covered in fine, powdery dust, but also riddled with hidden rocks, craters, and slopes. The lunar surface is unpredictable, and every mission faces the challenge of finding a safe, stable spot to land. Even the Apollo missions, with all their planning and precision, had some close calls. One wrong move, and the whole mission could have ended in disaster. Gravity's only a sixth of what we've got here, so landers bounce, slide, and tip like they're auditioning for a slapstick comedy. When a lander touches down, it doesn't just stop, it can skid, wobble, or even bounce thanks to the moon's low gravity. And with so little weight holding it down, even a small bump or a patch of soft dust can send a lander tilting dangerously. It's like trying to balance a chair on a trampoline, one wrong move and over it goes. And that soft, crumbly regolith, not doing any favors, it's like trying to park on flour. The moon's surface is covered in a layer of fine, powdery dust called regolith, which can be several meters deep in places. This stuff is so soft and loose that it can swallow up a lander's foot pads, making it even harder to stay upright. Imagine trying to set up a tent on a beach made of powdered sugar. No matter how careful you are, things just keep sinking and shifting under your feet. Now, check this out. Engineers have discovered the scutoid, a funky, twisted shape scientists first found in cells. The scutoid isn't just a cool name, it's a geometric marvel. Originally discovered in the study of how cells pack together in living tissues, the scutoid is a shape that's part prism, part twisted polygon, and totally unique. It's got flat sides, curved edges, and a kind of kink in the middle that lets it fit together with other shapes in ways that ordinary cylinders or cubes just can't. When scientists first saw this shape in nature, they realized it was perfect for creating strong, stable structures, whether in biology or in engineering. Turns out this geometric oddball is perfect for lander legs. Traditional lander feet are usually round or flat, designed to spread out the weight and prevent sinking. But on the moon, that's not always enough. The scutoid's unique shape allows it to grip the surface, adapt to uneven terrain, and distribute weight more effectively than a simple circle ever could. It's like giving the lander a set of all-terrain tires instead of old-fashioned roller skates. Instead of boring old round foot pads, scutoid-shaped feet can grip, adapt, and stay stable, even when things get rocky. The scutoid's angles and curves let it bite into the regolith, finding purchase where a flat pad would just slide or sink. This means a lander can touch down on a slope, a pile of rocks, or even a patch of loose dust, and still stay upright. It's a game changer for lunar exploration, opening up new landing sites that would have been too risky before. Imagine swapping flat snowshoes for spider legs. Sounds creepy, but it works. Spider legs are nature's answer to rough terrain. They can grip, flex, and adjust to almost any surface. By mimicking this approach with scutoid-shaped feet, engineers are giving lunar landers the ability to walk, or at least stand, on ground that would have been impossible before. It's a blend of biology, geometry, and robotics, all working together to solve one of space exploration's oldest problems. Why does it matter? Because if we want to send astronauts, robots, or even habitats to the moon, and not just once, but over and over, building a real presence there, we need to make sure our landers can handle whatever the lunar surface throws at them. Future missions will be landing in places we've never been before, near the poles, in deep craters, or on rugged highlands. These areas are rich in resources, but they're also some of the most challenging terrain on the moon. If our landers can't stay upright, we risk losing not just equipment, but entire missions and maybe even lives. Keeping them upright is kinda important. A tipped-over lander isn't just embarrassing, it can mean the difference between a successful mission and a total loss. Astronauts need a safe, stable platform to work from, and robots need to be able to deploy their instruments and tools without worrying about falling over. Even habitats for future lunar bases will need to be rock solid no matter where they land. These scutoid feet could save millions, protect lives, and make moon landings way less terrifying. By reducing the risk of tipping, we can make lunar exploration safer, more reliable, and more affordable. Every successful landing means more science, more discoveries, and more opportunities to learn about our nearest neighbor in space. And who knows? The same technology could one day help us land on Mars, asteroids, or even icy moons far beyond our solar system. So next time you see a lander with weird feet, you'll know it's not a fashion statement, it's geometry, saving space missions. The scutoid might look strange, but it's a symbol of how creative thinking and a little inspiration from nature can solve even the toughest engineering challenges. As we prepare to return to the moon and go beyond, it's these kinds of innovations that will make the difference between success and failure. Would you trust a scutoid-legged lander to bring you home from the moon? Let me know below, then subscribe, and stick around for more out-of-this-world science. The future of space travel might just depend on a shape you've never heard of, until now. So next time you look up at the moon, remember, it's not just about rockets and astronauts. Sometimes it's the weirdest geometry that keeps us standing tall on new worlds.